Good morning, sir. My name is Banerjee. I am from Mechanical Engineering Department, Dr. BC Engineering College, Durgapur, and we are going to discuss about our project, which topic is experimental analysis of surface roughness of steel by considering variable cutting parameters for turning. Firstly, I am very thankful to our project guider, Dr. Manoj, Kundu sir, and my team member is Rajnish, Ranjan, Rajkumar, Bharti, and we are second. I am coming our slide plan. First is title, second is abstract, third introduction, fourth experimental details, fifth observation, sixth result and discussion, seventh conclusion, or eighth future scope or references. Now I am going to abstract. This paper presents result of experiment conducted in order to analysis of surface roughness of steel by considering variable cutting parameters for turning. Surface roughness measurement is a critical aspect of quality control in manufacturing process, particularly the context of lathe and milling machine operations. Basically, we know that, and this abstract provides an overview of the methods, tools, and significance of surface roughness measurement. This machining process it explores the key techniques such as stylus, profilometry, and optical interferometry that are commonly employed for assessing surface roughness. And now I have come to introduction. In the field of precision manufacturing, achieving the desired surface finish of a permanent important surface. Cause surface roughness is a vital role which plays in industry field when many components will break about surface properly surface roughness. And we have at first we read also this literature review and which I have mentioned here. And experimental setup. At first we have used a steel which properties are also there mentioned, and first we are this performance on lathe machine with attached the job. Second, the job contacts with the job tool bit. This is our tool bit, and this is the job, and we are use a sandpaper for better finishing, and thereafter we use surface roughness measurement tester. And now I am introduce our second partner to come with and complete the next slide plan. Thank you.
Thank you, Ayan. As Ayan, my friend, said that we are doing the surface roughness test of mild steel, which contains properties of tungsten and carbon 0.5 to 0.8%, and one more compositions is there. I would like to say that when we are doing our experiment on mild steel, we have changed RPM according to our requirement and depth of cut, and how it came to the roughness, how it is increasing or decreasing. We have to see for our future. So we have taken the observation like feet we have taken, and after that according to that depth of cut we have changed 3 times, and according to that we have got the roughness. See, you can see that so the roughness is decreasing when the RPM was 274, and according to that feet first we taken the feet and 0.1209, and the depth of cut was this, and we got the result of roughness this. According to that, after we have changed the RPM, second we took the RPM 186, and in that we have kept the depth of cut constant as we kept in previous RPM was 274. So according to the depth of cut we kept constant, and so we have kept the 3 depth of cut as in the previous RPM. The depth of cut was 0.75, then 0.6 and 0.5. And this all 3 depth of cut we kept same for the RPM 186. We reduced the RPM and the feed rate which constantly decreasing, and this affect the roughness. As you can see that the roughness is also decreasing, and I would like to say you in the third of RPM we took that actually we are decreasing the RPM. So now we took the RPM 124 because previously it was 186, and it was before this it was 274. Now decreasing. So you can see that this is also same. The roughness is decreasing when we are decreasing the RPM. Then it affects the roughness, and we are decreasing the feed. So this is also affecting the roughness. Now in the fourth slide, we thought that if we keep the depth of cut as 0.75, then we are increasing the RPM, as we have taken the same RPM in the first slide and the second and the third. We have checked that in the graph that what is the result coming. The result is the same, that when increases the RPM, the roughness also decreases. Due to that, we have we have the graph result. You can see that in the first table it was 274 and the feet was this and the depth of cut was this 0.75 and 6.5 and the roughness this. So we have plotted this in a graph. You can see that this is actually decreasing the roughness. This shows that the roughness and this is the feet. Actually this is decreasing. So we can say that the surface roughness decreases when the feed rate and the cutting speed, means the RPM, is kept fixed. In the second slide, second table of the roughness versus depth of cut. This is also showing that this is also decreasing. Depth of cut, when the depth of cut is increasing, the roughness increases. Means vice versa, surface roughness increases with decreasing the depth of cut. In this also, the RPM is fixed. In the last slide of the graph, I am showing that the roughness and versus RPM. When RPM increases, you can see that this is the plot of the graph according to 0, then the interval is 50, then 100, 150 and 200 and so on. When we plot it, I can show you in the table. This 124, 186 and 274, the RPM increasing. In this RPM increasing, then the roughness is also decreasing. You can see that it was there and the first roughness was 3.20 and now it is between 150 and 200. The roughness is decreasing 2.621 and again this when it comes between 250 to 300 RPM, it is roughness decreasing. Means we can say that when we increase the RPM, the roughness decreases. Now I would like to tell my group member, third member Rajnish to conclude with our project.
Rajkumar, now I will conclude the rest part. Before conclusion, we are going our previous slide. From that, we see that when the feed is decreased, the roughness is also decreased, and when we decrease the depth of cut, the feed roughness is also decreased. But in case of RPM, when we increase the RPM, that time our roughness is decreased. And we are like based on the conclusion provided, we see that when feed rate and depth of cut is decreased, and surface roughness value also drop. But in case of RPM increases, the roughness value is decreased. And we are now going to feature scope. In feature, we can change many type of material. We use other type of machine. Now we are working on mild in feature. Anyone can change the material that like aluminum, brass, and change the machining process, temperature included. Now we are going to reference part. Our friend is already tell that the references. This is the literature review. Before our studying and starting the project, we are reading many type of literature. From that, already our friend is explained that part. And now DP Selvan and Peter Mohan, influence of cutting speed, feed rate and bulk test form. That type of experiment is already completed, and many literature review are. And DP Raj and Peter Mohan are research many type of project. And before our studying that project, I already said that we are studying that part. And there are already 10 research paper we are studying, 10 general paper, and we completed our project. And our project mentor Dr. Manoj Kundu sir, which we guided us, and we completed our project. And also thank you for Rajkumar, Bharti and Banerjee. Thank you.